In the last one decade, we have seen exponential rise of batteries around us. It could be either due to increased usage of electric vehicles or increased consumption of other electronic devices. Many a times, the discarded batteries used in these devices often end up at our nearest dumping yards, leading to possible health hazards for the environment and the human beings. In our latest episode of Startup Talks, we are joined by Mr. Vikrant Singh, who is the co-founder and also the Chief Technical Officer of Batex Energy. Let's move to the interview to know more about how this company is tackling the issue of battery recycling. This is Manish Kumar and you are watching Startup Talks.
Actually, that whole journey was started in a competition. So when I was in second year of my mechanical engineering from BMU, and there was an event because I was more passionate about building the cars. So we were building an electric car, and at that point of time, what happened? College said that you will only if you will participate in electric cars, we will going to fund you. So we started building the electric car. We have made the full budgeting of the car. Then we have realized that lithium-ion battery is being used into the electric vehicles if you want to participate into the competitions. And that was a very new word, that lithium-ion battery is something which is being used. So we have started working on that okay, we will build a car. And once we have started working, we have seen that the total battery or the car budget was 8 lakhs. And the battery cost itself was 8 lakhs. So that means the whole budget was going into the battery itself, and that is something which intrigued us, that there is something which is there inside the batteries. And that battery was, the lithium-ion battery concept in India was very new. Very few people were knowing that automotive battery is also, lithium-ion battery is being started. So we have explored that where we can get the battery. That battery, we have seen that this battery will be imported from Korea. And that was something which I told my co-founder. So Utkarsh is my co-founder and he was into the management team. So I asked Utkarsh that I want to source this battery. He said that this battery is not being built in India. You have to import from other countries. So I said this is something which don't have a budget. And that was the point where we two have aligned together, that this is something which is a core and which is not available in India, we can do with something. That means the whole story was started as a problem solving rather than going for the startup or something, that we will solve this problem of battery manufacturing in India. We started working in the BMU campus in a laboratory. So there is a laboratory here, especially in terms of clean lab, where you can actually research in the nanomaterials. So we started working with the machinery like scanning electron microscopy, Raman spectroscopy, nanomaterial research spectroscopy, and we found that this battery can be built in India. So technology we have sorted. So within 2 years, we built the first cell inside the college. And then when we have stepped outside the college after graduating from this college, we realized that this is something which can't be done on a commercial scale. A business can't be done with the cell manufacturing because you need very large funds. Minimum is 200 million you will be needing to establish a lithium battery manufacturing, especially the cell. And then we have intrigued an idea that let's extract the material from the old scrap batteries. For example, the batteries are running in laptops, in mobile phones, in EVs. So we thought that if we can extract the material from scrap cells and then we can utilize into the new cells. So still the idea was to make the new cells. Then we have entered into it, we explored the market, and then we have realized this market is still itself a very huge market to cater into the future. And that's where we have started this Batex as a recycling company and started the research in the first frame. It was only an idea, and then we have researched in some of the ways. We have found that this technology we can create in-house. So in college, between the year 2020 to 2021, we have only researched about how to get the processes to get these materials out, like lithium, cobalt, nickel, manganese, which is the essential part to build the cell. And after building and making a lab scale technology, we thought that let's go outside and let's start something in terms of production. And then we have taken that lab scale to the commercial scale production in terms of getting the black mass out. So the major challenge was at that point of time that there was no one in India who was doing the battery recycling on a commercial scale. So you are not having any infrastructure to support. You don't have any understanding of testing laboratories. You don't have an ecosystem to build that, right? So we thought that how to do it, because you need very high cost equipments to test the material. And we have started building the ecosystem in-house before getting into the production or kind of company. So that is something which was the start, which we realized later on once we have built the technology, we have taken it to the commercial scale. And now we are processing around 200 metric tons of battery waste every month, which is equivalent to 20 million batteries every month we are recycling at the today's date. So that is scale we have reached so far. So in batteries, there are a lot of elements. If you convert into terms, so we can convert in two forms, especially the elements like lithium, cobalt, nickel, manganese, and in terms of copper and aluminum. So there are major 8 metals which are found inside the lithium-ion batteries, and that makes the lithium-ion batteries the more costly elements, because the materials like lithium, cobalt, nickel, manganese are very critical materials, especially if you leave the manganese. So if you convert lithium, manganese, and lithium to cobalt and nickel, they are very costly materials because their availability on this earth is very limited. So in lithium-ion batteries, especially these materials are responsible to produce the charge inside the battery. So as of now, the major challenge is to put back into the lithium-ion batteries again, because it is a very nascent stage where the technology of lithium-ion battery is being there. Still, you have seen that lithium-ion battery technology is being upgraded, or innovation is being happening at every month in terms of lithium-ion battery technology. To utilize into the new cells at the lab scale, already it is being established right now. But to take it on a commercial scale, it is little bit challenged because the supply chain is not being created, especially to make it more commercial to use in terms of supply chain. Now, why it is not being there? Right now, the materials which we are extracting is going to pharmaceutical industries, paint industry, electroplating industry, and in other industry like aerospace industry, especially to cater the demand of these materials. Our target is till 2025. Our main target is to utilize this material inside the batteries. So we are creating an infrastructure. Even the infrastructure is being also created by the market also, because in India there is no player who is into the cell manufacturing. So until unless there will not be cell manufacturing business in India, the utilization of this material cannot be done in-house in India itself. So at the moment we are exporting these materials from outside the India for the other uses. So that's right now we are doing at the moment. Definitely there are a lot of technologies which is being built, and this technology is not simple. It is very complex to extract these materials with the way the Chinese people are doing, right? And that is where the challenge comes in. In the Batex right now, we are not into the commercial scale, we are not into the lab scale. Right now we are processing 200 metric tons of battery waste every month, which is something we have already commercialized the technology which we have created, and we have proved that the business can be done in this sector by using our technology. The major challenge today's world is that you have variety of batteries, right? And even no one has a data that what kind of battery is flowing in the market. For an example, your Apple phone, Apple 14 is having different kind of battery, or maybe Apple some other version is having different kind of battery. So you can see the difference in one model. So how the variety of battery will emerge from telecom sector, portable electronic, laptops, mobile phones, electric vehicles which are coming. So to recycle any kind of battery into a single platform is really a challenge for the industry. So the technology which we have created, which is called chemistry agnostic technology, you can process any kind of battery into a platform with the same yield, the same purity which we are extracting at the moment. Second is, majorly if you see the global, people are following the pyrometallurgical technologies. That means you heat that material with a very high temperature. In that situation, there is a high energy consumption process, as well as this process is not sustainable. There is a lot of emissions which is being happening into that process. We have developed a hydrometallurgical technology which enables this processing of this battery in a sustainable way. So you are not emitting to anything to the environment in terms of solid, liquid and gas. So that makes the whole process a closed loop process, so extract these elements in a sustainable manner. This technology is scalable. You can scale from 10 tons to 10,000 metric tons. So that is something which we have achieved so far in terms of creating a commercial viability of the technology which we have achieved at the moment. So as you know, these batteries are very hazardous, right? So there are definitely two impacts, larger impacts which we see. One is the hazardous impact to the society, to the biodiversity. It is because the cobalt and these materials are very, very heavy elements. They can cause cancer, they can cause a lot of diseases if this being exposed to the environment. So that means if you're dumping these batteries to anywhere else, it is already damaging to your environment. It is damaging your water, that means the groundwater, because once it is being dumped to any of the environment, when it rains, so a lot of water seepage is being happening to the ground. So that means these metals are also mixed with the groundwater. This is the one side of it which is affecting the biodiversity. Second is, it is our responsibility to preserve the natural resources, because it is limited on the earth, right? You have limited resource on the earth, and one day it will finish. For an example, fossil fuels. You have seen that these fossil fuels are depleting day by day. So it is also a limited resource. You need to reserve that, right? So this is something which is very important, that if you are not recycling, that means the consumption of these materials are happening and lying down to somewhere else. So that means definitely there is a demand supply gap someday. So to preserving these materials are also very necessary, and using back into the supply chain. That is where our target is also, and that need to be done in terms of waste management. This is very important to preserve these materials for our future generations. I think there are major four-wheeler OEMs. We have tied up with them. There are certain fleet operators which are we have tied up with them, which are into the four-wheeler manufacturing. There are a lot of companies which are in two-wheelers also. We have tied up with them. There are a lot of fleet operators which are into the, for an example, battery smart. So they are leasing their batteries, in terms of getting them in the market. So we are also tied up with these players to get the batteries back. And most importantly, we need to understand that company owner is not the owner of the battery. So the customer is the owner of the battery. So we need to focus on the customer supply chain, because we need to focus on service centers. We need to focus on exchange of the battery which is being done. That will be the major chunk in the future market to get these batteries back, because once the battery is being made, the customer will decide whether they have to sell the battery. So we have to tap the customer segment, and definitely we have long-term tie-ups with a lot of players in the industry which are being imagined right now. At the moment, we are confined with the lithium-ion batteries. Not only lithium-ion batteries, anything related to the critical materials. So for an example, if next battery comes with any other critical material, we'll go into that space. But we will not go for the lead-acid battery recycling. It is simple reason, because supply chain and the technology always being saturated. And at the moment already there are a lot of players which are doing that, solving that problem. So it's not only the doing the business, it's also the solving the problem. So we want to solve this problem which has been emerging at the moment, and it is only we want to confine ourselves in terms of getting up the critical material recycled, maybe a lithium, cobalt, nickel, manganese and other materials too. If that batteries are being built in India, definitely we will in a space to recycle those batteries. A lot of news daily you will see that some new sodium-ion batteries coming into the future for the electric vehicles. Someday you will learn that sodium-ion, or you can say hydrogen, is coming into the future, that hydrogen can replace the lithium-ion batteries. But if you see the reality, because commercialization angle with the research angle is very different. We need to think in terms of how the commercialization will change the customer mindset, because ultimately this technology is being adopted by the customer itself, right? In terms of coming to the technology, sodium-ion is very far behind with the lithium-ion technology. It's because of the few challenges. One is that the energy density. That means if in 1 kg, for an example, lithium can give you 200 to 250 watt hour of the energy, which sodium can't. And it is because of the simple reason that It's a natural benefit which lithium is getting in terms of getting a density. So still the technology is at a very nascent stage. Definitely the technology can be viable for lead acid battery replacement. Lithium-ion battery will have a market segment, especially for electric vehicles. Second, hydrogen. You know that in hydrogen there is a challenge in getting the infrastructure, right. The production of hydrogen is very critical, very complex. The safety of hydrogen storage is still a challenge into the future. In terms of hydrogen, the major challenge is not the technology. Major challenge in hydrogen is that you use 100 rupees of electricity to manufacture 110 rupees of, or you can say 90 rupees of hydrogen. That means we don't have other option rather than electricity to manufacture hydrogen. So that is a unit economy game. That will still a challenge. It will take a lot of time to be stable, but we want to come into the play because it's more renewable, it's more sustainable, it's more greener. If it can be explored, definitely lithium-ion battery will play an important role for storage. So definitely we see around 1 to 2 decades of lithium era which will be there into this day one without any doubt. We have created an ecosystem of the manpower. Technology is one side. Definitely we have created a cutting edge technology which enables to recycle any kind of battery into a single platform. The production cost is very less and we are more competitive with China. So definitely it becomes more sense with our technology to recycle this battery in India itself and become more viable, because in our technology it's completely profitable business which we are doing right now. The achievements which we say that initially in India when we have started, there was no ecosystem of testing of materials, right? Because India don't deal with the critical material refining till yet. So they don't have infrastructure to test it. They don't have a manpower to work into this kind of domain. So from 3 years, I think the best achievement is we have created the ecosystem of research, innovation in this nanoscience, and that is something we have created a manpower, skilled manpower into this sector, which will enable this sector to research more and to make India self-reliant in terms of technology, in terms of production, in terms of creating their batteries by their own. So that is something which we see a way forward to build an ecosystem, whether a research center, whether a testing centers, whether production. So that is something which we have created. If you talk about our inert achievement which we have done, we will call it as the scale which we have reached at the time, it is something which we are matching with the market. Second is, in this market the supply chain is a backbone of the business. Once you have built the plant, you will be needing the supply chain to feed the plant. Right now we have built a very strong supply chain pan India, so we can lift the material any parts of the India at today's moment. We have tied up with a lot of reverse logistic companies. We have built our own warehouses to store the batteries nearby that area, and that is something which we have very strong hold in sourcing the batteries from pan India to source these batteries. So that means the challenge was to source these batteries, which we are solving day by day in terms of getting these batteries back to the supply chain. This technology of whether it's a lithium or recycling is very new, right? Initially these batteries were used in mobile phones and laptops only, especially the power electronics, right? The concept of EV comes 5 years earlier, right? 5 or 6 years earlier. In 2014-15 the concept was started in India, especially in commercialization. So India also is a very nascent stage in terms of technology, in terms of the policies. So at battery side, there are a lot of policies which are coming, because manufacturing policies are needed in the starting to build that policies to make it standardized. Second part is in recycling sector, definitely government has revised their waste management policy. They have segregated the battery waste management with the electronic waste management, which was earlier it was in the same segment. And the new policy came which is called battery management rules. In 2020 they have published one policy which states that EPR will also govern into this battery field. So in simple terms you can say that there will be a producer who is producing the battery. Now it becomes a responsibility of the producer to recycle their batteries after their end of life. Second is the clause is being there into this policy that anyone who is building the batteries, at least 20% of the material should be used, of recovered material need to be used in the new batteries, and it is being mandated for battery manufacturing. That means indirectly it is boosting the recycling companies to recycle their batteries and getting this back into the battery manufacturing again, because this battery is something which is related to energy security, right? Earlier the energy security is the fossil fuels, where India is dependent on fossil fuels, getting the import of oils, right? A lot of physical deficit is being created by the oil import, right? Because any country, if you want to sustain, it will be dependent on the energy. Battery or the materials are next fuel generations. It is fuel for next generation. So for an example, earlier the oil is the energy, now the materials are energy. And in fossil fuels, when the fossil fuel is being burnt, you cannot recover it again. But in battery, you can rebuild these batteries as many times you want to be. That means this material can be used infinitely. So the policies government is working on, especially FAME 1, FAME 2, FAME 3 schemes, are for government manufacturing of batteries. PLI scheme is being launched by government, so a lot of incentives is given in cell manufacturing domain. In battery field, there is not direct policy which has been, or a scheme which is helping, but there are a lot of indirect policies which are helping recycling companies also to build a large ecosystem. They are helping in terms of research and innovation, especially the Ministry of Heavy Industries. They are helping the startups to do a research. DST, Department of Science and Technology, are also helping to develop the technologies in terms of testing platform. DSIR, it is a body which is onto the industrial scale. They are also helping to build the technologies, to help them to build the technologies, collaboration of different companies they are doing with the government institutions to make this whole battery recycling a commercial platform. So definitely government, at every angle you see, government is playing a very important role in terms of developing the technologies, making it commercialization and standardization, because there is no standardization till now, right? That how battery will be in terms of storage, the authorization of these batteries. So now that is already being into the market, that there is an authorization which is being given to the recyclers, and recyclers can give that authorization to the producers. So that is already being playing into the market, and in the future, according to our study, that definitely the government will play a very important role in regulating the materials by QR code, which is called battery passport. So battery passport is nothing. So when you manufacture the battery will be given a code. So government will track that this code of battery, where it is flowing from utilization to the second life utilization to the recycling, which is already being happening in Europe, because these materials are very critical, very limited. So we need to understand that if you want to make your country self-dependent, these materials regulation is very important. So that means you need to restrain that metal should not go outside the country. It need to be utilized in the country again. So that is something we say that definitely government is helping in a lot of policies. Still we are waiting for some policies to get it standardized. I think very soon we will see from the government side. Definitely we have I think right now we have applied 8 IPs till so far. The IPs are not limited to design. IPs are into the process, into the design, into the holistic circuit. So that means we are not making innovation only in the chemical side. From supply chain side, how the supply chain will be regulated, we have some IPs. Second is how the mechanical processing will be done. We have design and process patents. Still this patents we have applied, it is being applicable for 37 countries including Europe and US. In terms of chemical plant, that means the extraction part, right now major of the patents is being held by China, but now we have filed 2 more patents, especially in chemical field, which will protect us on the IP basis in terms of doing our operations. So it already regulates that we are very strong in terms of innovation, in terms of continuous improvement, which is called Kaizen, and that will be reflected by the giving the IPs. In the future definitely we will see a lot more IPs will be filed, especially on the nano materials, making this a battery grade material again. So that is something our team is working right now, and we want that. Already we are secured with the intellectual property, especially for the process and design. In today's time, definitely China is having the upper hand, not for the India, for the whole world. In today's time, if I give you the number, 90% of the total world's recycling is being done by China. That means any battery which is in Europe, in US, Middle East, India, it is going to China ultimately, and they are having a very large capacities and technologies to recycle these materials. And that is something, it is because the China has started with the cell manufacturing, because they are largely into the cell manufacturing or battery manufacturing, so they have created this ecosystem in the starting, right? So at the moment we say China is having very deep advantage of technology and the scale, but based on the government incentives which are getting right now and the policies, because now China is not accepting any scrap, so they have regulated that they will not accept any scrap from other countries. So now we have a chance, we have a very good opportunity to build the capacities more than the China, because India is a very, very large country. It is having a very, very big market, especially in terms of the lithium and battery field, because utilization is not only the electric vehicles. Right now you will see every field, whatever electronics, EV sector, telecom sector, laptops, mobile phones, small stationary applications, commercialization, small applications like hospitals are also replaced with the gensets. So the market is very large. According to our reports, if we can, the players which are emerging in India, not only the Batex, if other players are also emerging in India, if we can build a very large capacities with a very good unit economics and technology, we can be on the top of the China in maybe next 5 years. So that's the plan right now, which we are on it. This technology of whether it's a lithium or recycling is very new, right? Initially these batteries were used in mobile phones and laptops only, especially the power electronics, right? The concept of EV comes 5 years earlier, right? 5 or 6 years earlier. In 2014-15, the concept was started in India, especially in commercialization. So India also is a very nascent stage in terms of technology, in terms of the policies. So at battery field, battery side, there are a lot of policies which are coming, because manufacturing policies are needed in the starting to build that policies to make it standardized. Second part is in recycling sector, definitely government has revised their waste management policy. They have segregated the battery waste management with the electronic waste management, which was earlier it was in the same segment. And the new policy came, which is called battery management rules. In 2020, they have published one policy which states that EPR will also govern into this battery field. So in simple terms, you can say that there will be a producer who is producing the battery. Now it becomes a responsibility of the producer to recycle their batteries after their end of life. Second is, the clause is being there into this policy that anyone who is building the batteries, at least 20% of the material should be used, of recovered material need to be used into the new batteries, and it is being mandated for battery manufacturing. That means indirectly it is boosting the recycling companies to recycle their batteries and getting this back into the battery manufacturing again, because this battery is something which is related to energy security, right? Earlier the energy security is the fossil fuels, where India is dependent on fossil fuels, getting the import of oils, right? A lot of physical deficit is being created by the oil import, right? Because any country, if you want to sustain, it will be dependent on the energy. Battery or the materials are next fuel generations. It is fuel for next generation. So for an example, earlier the oil is the energy, now the materials are energy. And in fossil fuels, when the fossil fuel is being burnt, you cannot recover it again. But in battery, you can rebuild these batteries as many times you want to be. That means this material can be used infinitely. So the policies government is working on, especially FAME 1, FAME 2, FAME 3 schemes, are for government manufacturing of batteries. PLI scheme is being launched by government, so a lot of incentives is given in cell manufacturing domain. In battery field, there is not direct policy which has been, or a scheme which is helping, but there are a lot of indirect policies which are helping recycling companies also to build a large ecosystem. They are helping in terms of research and innovation, especially the Ministry of Heavy Industries. They are helping the startups to do a research. DST, Department of Science and Technology, are also helping to develop the technologies in terms of testing platform. DSIR, it is a body which is onto the industrial scale. They are also helping to build the technologies, to help them to build the technologies, collaboration of different companies they are doing with the government institutions to make this whole battery recycling a commercial platform. So definitely government, at every angle you see, government is playing a very important role in terms of developing the technologies, making it commercialization and standardization, because there is no standardization till now, right? That how battery will be in terms of storage, the authorization of these batteries. So now that is already being into the market, that there is an authorization which is being given to the recyclers, and recyclers can give that authorization to the producers. So that is already being playing into the market, and in the future, according to our study, that definitely the government will play a very important role in regulating the materials by QR code, which is called battery passport. So battery passport is nothing. So when you manufacture the battery will be given a code. So government will track that this code of battery, where it is flowing from utilization to the second life utilization to the recycling, which is already being happening in Europe, because these materials are very critical, very limited. So we need to understand that if you want to make your country self-dependent, these materials regulation is very important. So that means you need to restrain that metal should not go outside your country. It need to be utilized in the country again. So that is something we say that definitely government is helping in a lot of policies. Still we are waiting for some policies to get it standardized. I think very soon we will see from the government side.